In the previous examples, we looked at solving problems with related to normally distributed data. In each case, what we saw was we had to draw a normal curve, and we had to label the x-axis for each of the examples. But what stayed the same were the percentages. So regardless of what the x-axis ended up being labeled for that specific data set, these percentages stayed intact. Well, it would certainly be nice that since there is this consistency and the percentages stay the same, it would be nice if we didn't necessarily have to create a new normal curve for every single set of data that we encounter, especially because so much data is normally distributed. So it becomes terribly inefficient every single time we have a new set of normally distributed data to do it the way we were. Instead, there is a shortcut. What we do is we generalize our information, the data that we have, so that we can work off of just that one normal curve that you were originally introduced to. Remember, in general, we had x bar, and then we were adding on and subtracting standard deviations. And this was in general how we would write it. But remember, those percentages stayed the same. So what we're going to do is talk about how we can take the information for all of these different data sets and generalize it so that we might work off of this one normal curve. Let's see how this works. We're going to get what we call a z-score. A z-score tells us how many standard deviations a data value is away from the mean of the data set. We find the z-score by taking the data value, subtracting off the mean, and dividing by the standard deviation. Let's take a look at how this works for our pop bottle example. Let's find the z-score for our data value of 10.59. So we take our data value of 10.59, subtract off the mean of 12, and divide by the standard deviation. Remember, the standard deviation for machine 1 was 1.41. When we simplify the numerator, we get negative 1.41, and when we divide that by the denominator, we get a negative 1. All right, check this out. If we take that z-score of negative 1, what that tells us is that we are one standard deviation away from the mean. But remember what a negative tells us. The negatives and positives imply direction. So we are one standard deviation below the mean. In other words, subtract the standard deviation just once. That would put us right here. The question is still the same. What percent of pop bottles will be filled less than this? Okay, well, if you check this out, here we are at a z-score of negative 1, and the percent of pop bottles below this, or the percent of data in general, is 15.85%, which is approximately 16% of the data. If you think about how we did it the long way, we went through, we created the normal curve, we labeled the x-axis appropriately, and then we located our data value of 10.59, and we found the percent that was below that. We get the exact same answer. It's just in the way we did it now with the z-score, we will not have to create a different normal curve every single time. In the next video, you'll see how we can use this general normal curve down here for machine 2 as well as for Quinn.